stage of it. So, just a few words about me. I work on in a simple startup called Sentinel. I like break stuff, and I like Asian food. So, you actually see lots of Super Mario over here, at least most of the presentation. So, before we actually begin, let's talk about attribution, why we actually need to unpack. Because if you want to unpack, you have to have some sort of reason. And you might want to actually blame someone for attacking someone else. So you actually want to attribute someone to do that for you. So we have basically 3 basic stages that you have to go through before you start unpacking. First one is you have to get on. That's pretty simple nowadays, because everyone's using APTs and stuff like that. Second one is you have to throw dice, and you have to tame some. The third one, you have to pick China, Israel, France, or whatever. And then you have to start unpacking, which is what we're doing. So, once we have a motivation to start unpacking, we can actually understand what's our main objective if we want to start unpacking. So, nowadays there are a few tools which try to help you unpack nowadays, but they're not really good. So, our main objective would be to actually achieve a scalable and reliable and stealth environment, which would actually help us to do it automatically and better. Or at least try to help us unpack more software which isn't unpacked easily. And secondly, we'd actually like to help our Johnny or our really reverse engineer who tries to get back software and try to help him do it faster or correlate to other stuff. But so a few words just about Johnny. He works in some 80 company or 5i company, and he has too many samples he needs to unpack. So we gotta help him somehow. And what we actually want to do is we actually want to look at some sort of graph which is like this, and we want to say the real program actually starts somewhere here automatically. So let's talk a bit about the actual infrastructure that we have over here. If you actually look at the unpacking problem, we actually see 2 main problems. We have like 60 to 70% hackers, which are pretty easy to look at, and are mostly employed to do file fully undetectable stuff. And then we have like 30 to 40%, which are pretty hardcore stuff, which will probably use some whiteboard obfuscation or metamorphic stuff and other stuff like that. And if we take a closer look at this kind of stuff, we can actually say that the simple stuff would actually employ classical anti-VM1, anti-debug tricks. They'll probably inject themselves or sleep, at least at some sort of stage. They'll probably have some classical compression, decompression, or encryption or decryption algorithms employed several times. And they'll probably, at least at some stage of the execution, large parts of the actual program would actually be visible. This is the first part of the project, this is what I'm going to talk about. Second part would be the actual hardcore metamorphic ones, which would be like code visualizer or Themata or other stuff, which basically means that you take one program and you actually transform it into VM code or whatever, and then you actually have to simplify it. Other stuff would be like ring interaction, like using the kernel or SNM or other stuff, and some probably other esoteric time effects and bugs which are probably important. So, if you actually want to look at it, what our infrastructure has to do is basically 3 basic stuff. It has to run the malware without being detected in a monitor environment. It has to unpack software, or at least try to help doing that. And it has to help us attribute someone, either by correlating and helping us find similarities, or either by just telling us, okay, this is the unpacked software, and this is the original entry point. So the first part would be actually achieving stealthiness, so having the ability to run malware in a monitor or in a controlled environment. And we can actually do that. There are basically 3 main ways in order to do that. First one would be to actually use a reasonable debugger like ODBG or some instrumentation framework like Trino and Amarillo. Second one would be actually to use a physical debugger. third one, we need to actually use a full system emulator like here in our box. So let's try to look at each one of those and see if they start working. So if we take a full physical debugger over